Hello everyone. Today video we are going to look at how to sketch the graph using differentiation. In this video I am not going to differentiate any function. I am only going to show you how to sketch the graph by using given function and its first derivation. For today's video I am used the 2020 A-level maths problem to sketch the graph of its fx function. As you can see, they given fx as x into 2x minus 3 divided by x minus 3 square, and also you have to show that the f dash x is 9 into 1 minus x divided by x minus 3 to the power q. I am not going to do the differentiate part, but I am using this fx and f dash x values. For there is the very manual methods, right? You have to just follow the steps and you can draw the graph very simply. So I'm going to show the what are these steps you must follow in solving this problem. So first we have to take the numerator and equal it to the 0 and find the x values. Those x values are the points that our graph intersect x-axis. So first I have to take numerator and equal it to 0. So according to my calculation, so this part I need fx function. So fx function they given that fx equals x into 2x minus 3 divided by x minus 3 square. So I am getting its numerator x into 2x minus 3 and I am equal it to the 0. So this is the product of two terms. If the product of two terms is 0, I can say that x equals 0 or 2x minus 3 equals 0, which means x equals 3 divided by 2. So I got the value 2x values for the first step. So these are the values where our graph intersect x axis, right? So I done my first step. So second step is take the denominator and equal it to 0 and find x values. Those x values are where the vertical asymptotes located. So by using denominator I can find the x values of vertical asymptote. So I'm going to take denominator of fx. So for the first two steps we use fx, right? So denominator is x minus 3 square. So I'm going to equal it to 0. Then I can get value x minus 3 equals 0, which gives us x equals 0. So at x equals 0, there is a vertical asymptote. Right. In these x values, graph intersect x axis, right? So my first two steps already finished. Now I am going to the third step. In third step you have to differentiate the given function fx and get the f dash x. I am not going to do that here. Then equal f dash x to 0 and find x values. There are turning points at those x values. So I am going to use the differentiated function, the first derivation of the function. So they given that. So you have to first derive fx and show the f dash x equal to 9 into 1 minus x divided by x minus 3q. I'm not going to differentiate, I'm just using this first derivation, right? So as the third step, I have to equal this to the 0. So 9 in third step, 9, 1 minus x minus 3q equals 0, which means 9, 1 minus x equals 0, and 1 minus x equals 0, 1 equals x. So at x equal 1, there is a turning point, right? So I found the turning point, x coordinate of the turning. After that, I have to find the y coordinate of the turning point. So substitute those x values to the fx 1 by 1 and find y values which are the y coordinates of turning point. So I have got only one x value, so I have to substitute it to fx, right? We only use f dash x to find the x coordinate of the turning points. In all the other parts, we use fx to get the details, right? So I'm going to substitute fx given that x 2x minus 3 x minus 3 square. I'm going to substitute x equals 1. At x equals 1, 1 into 2 into 1 minus 3, 1 minus 3 square, which led us to 2 minus 3 means minus 1, 1 minus 3 minus 2, minus 2 square means 4. So this is the fx always equal to the y. We can say fx equals to y. So this is the y coordinate of turning point. So by third step and fourth step, I found the turning for x coordinate and y coordinates of turning points. Let's move to the fifth step. So according to the fifth step, we have to draw the table below. So as example, they given that let x values of turning points are x minus 2, x equals minus 2, x equals 4, and x equals 6. So these are the x values of turning points, you have to draw table as this. But in our problem, we got only one turning point value, x value for the one turning point. So our graph is shorter than this graph. So in my case, I have to think about x equals, I think we get the x value as x equals 1 or something. Yes, x equal 1. So I have to consider, always we consider what happened near the turning point value. So first, if you observe this x values range, you can see that we always consider about what happened near the turning point value. So x equals minus 2. So when x smaller than minus 2, what happened? So when x greater than minus 2 and smaller than 4, because another x value is x equals 4. So when x equals 4, what happened? So likewise, you have to think all the x value range. So an important thing, in this x value range, there cannot be a asymptote x value. Think there is asymptote at x equals 1, then we can use this range minus 2 greater than x, smaller than 4 range we cannot use, right? We have to separate it to 2. We cannot take asymptote value in this table. So in my case, I'm going to draw my table as this. So my x value is 1, so my table is going to be like this. So my columns are, so rows are x, x and f dash x is the my rows. So first I'm going to write the x range, then the f dash x. Right. So first I have to consider about when the x value is smaller than 1, then x value equal 1, finally x greater than 1, x greater than 1. So by considering these three range, I can find the shape of the turning point. So we draw this graph to identify if the turning point is maximum or minimum, right? X greater than 1. So then I draw the table. Let's look at so substitute the x value match for the given range in above table to f dash x and check the answer is negative, 0 or positive, and fill the table using plus, minus or 0. So we have to check whether the f dash x positive, negative or 0, right? We don't need value, we just want to know the sign. It is a positive, negative or 0. So when I'm considering first range, so I'm first going to write f dash x here. F dash x equal to 9, 1 minus x divided by x minus 3 cube. So when x is smaller than 1, you can see when x smaller than 1, this value is positive, 1 minus x is positive, alright, 1 minus x is positive, and the x minus 3 is negative when x is smaller than 1. So negative, third power of negative term is also a negative. So I can write this term is a negative term. So positive term divided by negative term, finally I get negative value, right? You can think like that, right? Or you can substitute some value match for this range and observe it is positive or negative or something, right? When x equals 1, as you can see, 1 minus 1 is 0, then f dash x equal to 0. When x greater than 1, like you can see 2, right? Then 1 minus 2 means negative. So then when x is greater than 1, 1 minus x is negative, and this value asymptote, I think we missed something. What is an asymptote? At x equals 3 there is asymptote. So x greater than 1, so near point I think I take as 2, then 1 minus 2 is negative, 2 minus 3 also negative. So then negative divided by negative means positive answer. I got positive answer. You don't write some range value greater than, more greater than 2 or something, right? Because if you go furthermore, you meet asymptote, right? So this is not valid for the asymptote. So we can go till the asymptote, but we cannot pass the value of the asymptote. So you can use, for this question, you can use values 1 greater than x, smaller than 3, right? So if you substitute value in this range, you can get a positive answer for definite. So I'm going to write this as positive. So then I'm going to decide this turning point is a maximum or a minimum. So f dash means always shows the gradient of the graph. So gradient, f dash x is gradient. So first we meet negative gradient. We know the shape of the negative gradient is like this. Right. 0. Gradient is 0. So gradient is 0. Then there is no slope. Positive gradient, I can write it as draw as this. So by looking at this, I can say that my turning point is a minimum. So you can see this is a minimum shape, right? As wise, you can find the turning point is a minimum or maximum using this table. So I use that. So draw the shape of the tangents at the turning points using above table and recognize where the minimum or maximum. So I did that step also. So get the given function fx and check limits of it at positive infinity and negative infinity, right? So now I am going to check the limits at positive infinity and negative infinity. So do that, I get fx x 2x minus 3 divided by x minus 3 square. To check the limit at x at infinity, x lim infinity fx, I am going to check. So first I have to take the maximum power of denominator or numerator outside. So the maximum power I can see both numerator and denominator is x squared. So I am get x squared out of numerator and denominator. So I am get x from here, x squared. Then this term comes 2 minus 3 divided by x. I am taking x squared out, right? In here I got x, right? When x comes outside of the bracket, it's square, right? Then I can write it as x squared. This becomes 1 minus 3 over x squared. Right? Then I can cut the x squared. Then I can substitute the limit. Then 2 minus 3 over infinity divided by 1 minus 3 over infinity square. So we know that 1 over infinity is equal to 0 in limits lesson. We know that 1 over infinity is 0. So as you can see, then 3 over infinity also 0. So I can write this as 2 minus 0 divided by 1 minus 0 cube, which gives me 2. So when the graph x going to positive infinity, then the fx going to 2, and when the graph is going to negative infinity, you can substitute negative infinity. Then also you can see graph is going to positive 2. So I find the limits of the graph at positive infinity and negative infinity of x. Then near the asymptote, function go to the negative infinity or positive infinity. So at the asymptote, always function is or graph is always going to negative infinity or positive infinity. To check, you have to add some value, substitute some value near the asymptote, and can check it is a positive value or a negative value, right? Then finally you have to clearly mark all the data and gather from the above step and sketch the graph. So I already got all the details want to draw this graph. So I'm now going to draw the graph. So first I'm taking a Cartesian plane. Right? This is not a perfect graph, this is a sketch, right? Don't matter. Okay, this is I name axis as x and y. You also have to do that because naming axis is very important. So first I gather graph intersect x at x-axis at x equals 0 and x 3 divided by 2 here, x 3 divided by 2, right? 3 divided by 2. And there is a vertical asymptote at x equals 0. First I am going to mark the vertical asymptote. So I can mark vertical asymptote by dotted line. At x equals 0, I mark like this. So this is the vertical line at x equals 3, and this is we call asymptote. Right. Then I am going to mark my turning point. So my turning point is at x equals 1, y equals minus 1 over 4. X equals 1, y equals minus 4. So x equals 1 is like point like this, y equals minus 1 over 4 like this. So I can consider that this point is the my turning point, minus 1 over 4, x equals 1. Now I can draw the turning point shape near the turning point value. So I get that the turning point is a minimum, so I can draw shape like this. This is a minimum, so I can draw graph as this. And I know the graph intersect x-axis at x equals 0 and x equals 3 divided by 2. 3 divided by 2 means 1.5, right? So as you can see, if I draw my graph continuously, this must go through the x equals 0, right? And also this one is going to through the x equals 3 divided by 2. And right hand side of the graph meet asymptote. According to theory, we know that at the asymptote graph going to infinity. So we have to draw it at going to infinity. Then left hand side of the graph is going to there is no asymptote, so it is continuously draw. But we check the limit of the graph when the x is going to negative infinity. So this x value is going to negative infinity. So when x is going to negative infinity, graph is going to plus 2. We check it from the limits, right? So I get this point as this horizontal line as x equals 2. Right? Then the graph is going to like this. It is not going to continuously increasing, because when x is going to negative infinity, graph is going to plus 2. Also then we have to complete graph right side of the asymptote, right? So for the draw that graph, I have to find it is a negative or a positive value. So if I substitute value greater than 3 to the function, I can get it is a positive or a negative value. So as you can see, if substitute value greater than 3, it is a positive value. So if a positive value, graph come from the above. If it is a negative value, it is come from the below. So I can write it as this, and when x is going to positive infinity, graph is going to positive 2. So this is my sketch of the graph using differentiation. So you can check the marking sheet. They also must get the same shape as this. So you can use that steps, and following step bring you to the final result as this. So you can use that step to any differentiate graph for sketch it exactly right man. I think you get better idea how to get how to draw differentiation curve using fx function and its first derivation. So in next video, I hope to draw sketch another differentiation curve using these steps. See you in next video. And I'm attached the PDF file of the step in the description. You can download it and try to sketch past paper problems. It makes you perfect when you practice more. See you in next video.